Hey guys, so for the problem that the student is asking, uh, we are going to approach it by first labeling everything that's relevant. So to start off with, we know from the problem that the hanger is 30.6 centimeters off the ground when no mass is attached, right? Secondly, we know that when 150 grams of mass is attached, the hanger is 16.2 centimeters off the ground. The third thing is that when a wooden block is attached, the hanger is 21.2 centimeters off the ground. So the reason why I went over this is because I think that every time you approach a problem, that it is your priority, it should be your priority to write down the important facts that are relevant to the problem. And you should always do this. So the second thing is that we should now find the relationship between the mass and displacement. And the reason why we're doing this all in the first place is because we are trying to find the mass of the wooden block. So this is the first approach that we're going to take to find that mass. So find the relationship between mass and displacement. We're first going to find the difference in the displacement, which is delta D. Delta means difference. Some people don't know that. The difference in displacement between the hanger displacements when there is no mass and when there's a mass of 150 grams. So we had 30.6 centimeters minus 16.2 centimeters, which ends up with a difference of 14.4 centimeters. And the reason why you can't do 30.6 minus 21.2 centimeters when you're finding delta D here is because the whole goal of this part of the math or this problem is finding the relationship between mass and displacement. If we used 21.2 centimeters, the issue is they don't give us the mass of the wooden block. That's what we're looking for to begin with, right? So we can't use 21.2 centimeters because we don't have the mass of the wooden block, which is why we have to use the 16.2 because they tell us that it's that distance when it's 150 grams that are attached. So once we found delta D, we're then going to look for delta M, which is the difference in the mass between these two scenarios, which is going to be 150 minus 0, which adds up to a difference of 150 grams. So the third step is to find the rate of displacement per gram, right? Meaning how far is the hanger moving for every gram that's attached, right? So if I add 1 gram, what's the difference in displacement that's occurring, right? So just for another example, let's say you're working with an XY graph and I tell you a slope, a slope of 2 over 1, slope of 3 over 1, slope of 1 over 1. Like for slope of 1 over 1, that means you're going up y equals 1 and you're going to the right x equals 1, right? So that's the slope. So you're essentially finding the slope here, right? So you're going to do delta D over delta M, and you're going to get 14.4 centimeters divided by 150 grams, which is going to give you a rate of displacement per gram of 0.096 centimeters per gram. So that means for every gram that's added, the hanger is being displaced by 0.096 centimeters. So for the fourth step, we're finding the displacement caused by the wooden block. So we know that originally, without any mass, the hanger is 30.6 centimeters off the ground. But with the wooden block, it's 21.2 centimeters. So we find the difference, and the displacement difference is 9.4 centimeters. Now, when we're finding the mass of the wooden block in the fifth step, recall that in the third step, we found the rate of displacement per gram, right? So if we know that the displacement difference caused by the wooden block is 9.4 centimeters, and we know the rate of displacement per gram, we can now do the math. And by using the original formula, and what I did here, I didn't show it, but if you multiply both sides by delta M and divide both sides by 0.096, you're going to end up with this formula, which is delta M equals 9.4 divided by 0.096. And that's going to give you a mass of 97.9 grams. So, uh, I think this is pretty straightforward. Uh, if you prefer me to have shown the steps for this step, let me know. But I think overall this covers the problem. And if there's anything, just say something in the comments. Thank you.